So this is the third video for Notes 49, and it's the third problem. In order to graph this quadratic equation, we're going to be finding all of these little bits, parts, and pieces, and then I'll end with finding the domain and range. So the first little bit, part, or piece I find is I tend to find the axis symmetry first. So the opposite of b over 2a, x is equal to, your b value here is 6, so the opposite is going to be negative 6. All over 2 times your a value here is 1. It's a coefficient. So negative 6 over 2, axis symmetry is going to be negative 3. So we've got the axis symmetry, and that also means that we have the x value of the vertex, because for the graphs that we're doing, your vertex is going to lie on this axis of symmetry, and it's going to share the x value. Now, what y value does it have? Well, let's do a little evaluating. Whoops, right with a pen. Right with a pen. So everywhere there's an x, I'm going to replace it with a negative 3. And the rest of the problem, I'm just transcribing exactly as it's written. So y equals negative 3 squared is going to be 9. 6 times negative 3 is negative 18, and then a minus 7. Let's see what we got here. Negative 18 minus 7 would be negative 25. Negative 25 and a positive 9 should be, I believe, negative 16. We're going to go with that. All right. I like that answer. All right. So vertex here, negative 3, negative 16. On to our x-intercepts. So to find x-intercepts, we are going to set y equal to 0. And so that's going to be 0 is equal to x squared plus 6x minus 7. I'm going to factor that. So x and x, I'm going to zoom in just a touch. Let's see, what makes negative 7 when you multiply and positive 6 when you add? How about a positive 7 and a negative 1? Yep, that'll work. So x plus 7 is equal to 0. Take your factor, set them equal to 0. So x minus 1 is equal to 0. X equals negative 7. X equals positive 1. So one x-intercept is at negative 7, 0. The other x-intercept is at, whoops, as I write down x plus 1. Hold on one second. Let me edit that little piece there. X equals 1. So 1 comma 0. Like, something doesn't look right there. All right, so we've got our zeros. That we found those x-intercepts by setting y is equal to 0. So to find your y-intercepts, we're going to set x equal to 0. So back to the original problem, everywhere I have an x, I'm going to replace it with a 0. So y is equal to 0 squared plus 6 times 0 minus 7. So 0 squared 0, 6 times 0 is 0. So let's see, 0 plus 0 minus 7, I'm going to have a y-intercept of negative 7. So I've got all the bits, parts, and pieces that I need to graph my equation. I need the vertex, I need the zeros, and I need the y-intercept. The axis symmetry is nice to know, so I'm going to put that in place as well to see that whole idea of the symmetry of my graph. I'll get to domain and range in a little bit. So let's go ahead and start graphing this thing. So for my vertex here, negative 3, negative 16, I'm going to start off the origin, move to the left 3 spaces, and then drop way down to negative 16. And that's going to be where my vertex is. And then for my zeros, I have one x-intercept at negative 7, so on my x-axis. My other one's at positive 1. I have, let's see, a y-intercept of negative 7. So let's see, 5, 6, 7. Hold that thought for just a second. 1, 2, 3, 4. Yep, okay, I'm good. Just making sure I didn't screw anything up, because I'd hate to put out a video and have the problem be wrong. That would be horrible. But my teacher said do it this way, and your teacher's wrong. All right, so we've got the axis symmetry in place. And when I go to play connect the dots here, of course, it is going to be a smooth as you can make it, continuous curve. All All right, this is going to go through all those points. My curve clearly has some shape issues, but we'll go ahead and call that U-shaped curve close enough. Domain for our curve is going to be all the possible x values, and all the possible x values are going to be absolute everything from negative infinity to infinity. Graphically, if you're looking for domain, you're trying to figure out how far to the left will this graph ever go, and then how far to the right will this graph ever go. And again, no restrictions on your domain. Your range in this case does have a restriction. There is a low value here that your graph will never go any lower than, and that is going to be negative 16 is the low value. How high? Positive infinity. Negative 16 does take a bracket there. And that is your range. All right. I'm going to go ahead and do one more video, a separate one for problem number 4. This way you can pick and choose what you need to in the videos. As always, if you have any questions or concerns, please let me know, and I'll see you in the next one.